Vector Boot Camp video 2. Probably ran out of popcorn, so get yourselves something to drink because you're probably thirsty. Let's do some more physics. Here's a river. Say we got a raft in the river. My raft is baby blue, so I'll draw baby blue. Raft. Alright. And let's say the current flow is left. So in other words, the river is flowing in this direction at 8 meters per second. Alright? But let's say the person is rowing upstream to slow the raft down. That's actually what we do when we fly fish. We try and slow the raft down so we can cast into the different pockets and stuff like that. So the person's rowing upstream at only 4 meters per second. So the result is they're still going to be going downstream. They're not totally overpowering the river or anything. But those vectors are in opposite directions, so they cancel just like you would think. They don't completely cancel though. So all I have to do is 8 minus 4. So my V total, as we might call it, is 4 meters per second, and we'll just say left. Remember, vectors have a magnitude and a direction. Alright, just one dimension still. Okay, another example. Let's say we've got a dog bone right there, and we got 2 dogs fighting over it. We'll just draw it as a dot. And let's say this dog is pulling to the right at 60 newtons. Then we got another dog over here who's like a smaller dog or something like that, pulling with 40 newtons. Alright, and they cancel just like you would think. So later we will call the resultant vector of this addition, we'll call it F net. So F stands for force, net means total force. So the 60 Newton dog is winning. We are going to say that the F net on the dog bone right here is 20 newtons to the right. And we could also say positive direction. I use left and right here on these examples. Alright? So one dimension, it's really easy. You just subtract these two. Okay, now this is called vector addition, but we also are doing a lot of adding negative vectors to positive vectors. So we still call it vector addition. Now let's say these 2 dogs were working together. So they were both pulling right. Then I do 60 plus 40 and I draw this arrow the other way. So sometimes the vectors will work together. Or if this person is rowing with the river downstream, then the V total would be 12, and you could say downstream as your direction. Alright? So these 2 examples I did some cancellation. Alright, now let's break into 2 dimensions here. So we have our Cartesian coordinates here, and let's go hiking. Alright, so we got a hiker who's going to walk 300 meters north and 2,500 meters west. So our cardinal directions, we do never eat shredded wheat. But I'm pretty sure your teachers teach you never eat soggy waffles. So you guys grew up a little different on that one. Alright, so 3,000 meters north. I'm just going to sketch that like this and label it 3,000 meters. And then they're going to go over here, west only 2,500 meters. So I'm going to try and draw that to scale. It'll be a little shorter than this one. Now if this is an actual map, the hiker is going to be at this point and then going over here. But I don't want us to draw it like that because it will mess us up later. We draw all of our vectors from the origin. So no, the hiker did not turn around, go back to the origin, and go over here. Alright, that would be a different diagram. But I'm going to draw it like this because it helps us out with later problems. I'm going to label this 2500. And if I go over this much and up this much, I still end up right there. Okay, so I'm going to take a different color and draw my resultant vector out here. This is called the resultant vector. It's the addition of these two. Okay? And you can see if I draw some lines over here, this line's equal to that, and this line is equal to that. Alright, so now we just have to use Pythagorean theorem, because I've got an A side, a B side, and a C side, or a hypotenuse. Or I could say A, B, C, like that. It really doesn't matter. So we know that A squared plus B squared equals C squared, and the C is going to be my resultant vector. Alright, so let's do that. Type it into our calculators. Alright, I'm not even going to write it down, I'll just type it in here. Okay, so 3,000 squared plus 2,500 squared, and I get a big number, and then I got to take the square root of it to get C instead of getting C squared. So I get 3905. So C equals 3905 meters. Now what that represents is how many meters they are from the start. That's displacement. Now their total distance traveled, notice if I just add these, I'm not taking into account direction. Okay, so we could say over here D is equal to 3,000 plus 2,500, or 5,500 meters. That's meters that the person put on their boots. Alright, this is meters from starting place. So we call this a delta x. But it's not quite complete, because we have to figure out a direction. That is just a magnitude. Alright, now the direction. We are going to report the direction of our vectors from 0. So I'm going to have to give this angle right here. But I'm going to start, because I know that this part is 90, I'm going to start by just getting this angle. Okay, so I can actually use any trig function I want. So pick your favorite trig function. Hopefully you have one. Mine happens to be tangent. So I'm going to say tangent of theta is equal to opposite over adjacent. So this is theta inside here. And my opposite side is actually B. So that's the 2,500. Tangent theta equals 2,500. And my adjacent side is 3,000. So notice that the adjacent is not always the x side. Here the adjacent is the vertical side. So how do I undo a tangent? I inverse tangent it. So I can't just divide these and get a number. If I do that, 2,500 divided by 3,000, I get 0.83. That is not the answer. What I have to do is second tangent or inverse tangent of that number. So 0.8 and a bunch of 3's. Now I get my angle. So 39.8. Let's go over here to the diagram. Theta equals 39.8 degrees. But what I have to do is add 90 to that, so I'm reporting from 0. So 39.8 plus 90 is going to give me 129.8. We'll round it to 130 degrees. So my final answer is 3905 meters at 130 degrees. And this is always from 0. Alright, now in the navigation world, headings or bearings are always reported from north. So if you were asked to give one of those, you'd just say 39.8. But to keep it simple, we will always report from 0. In this case, that'd be the east axis. Alright, so we've got a magnitude and a direction. That is a complete vector. Alright, example 4. Vectors in 2 dimensions at right angles. If you think you've got this and you don't want to watch this part of the video, that's fine. You can skip it and you can go directly to this on the other side. These are the 2 that you need to do. But I will do this for a little bit extra practice, and I'll have you pause it so that you can check your work. Okay, so let's make up a problem here. Let's say we have got an airplane traveling at 250 meters per second. And let's say the wind is blowing in this direction at, how about 20 meters per second. Those probably aren't quite to scale, but it's just a diagram, it doesn't matter. Alright. Now if I do Pythagorean theorem, I can get this over here, and I'll change colors. This is my resultant velocity vector. Right? And what I did was I just drew it from here and here. Okay, I'll extend this a little bit. Fix my diagram. Now it's even less to scale. Oh well. Now I'm going to do a squared plus b squared equals c squared, and I'm going to find the angle from 0 all the way around. Alright, so pause the video, do both of those things, and then you can check and see if you're right. You can even fast forward the work I'm going to do and check and see if you're right at the end. Okay, so the Pythagorean theorem, I'm going to do 20 squared plus 250 squared, and you already have this done, you paused it. Now you're just checking your work with what I do. So let's get the hypotenuse. 20 squared plus 250 squared, square root of the answer, and I get 250.8. 250.8 meters per second. So that's how fast the plane is actually going to be going. So its engines are making it go 250, but this is called a crosswind. So that crosswind is taking it off course a little bit, and the plane's actually going to go in this direction. Alright, so let's figure out what the angle would be. So what I'm going to do is call this theta right here. And you could also call this theta if you wanted to, and just change your trig. And so I'm going to say tangent theta is equal to the opposite side, which is this, 250, over the adjacent side, which is 20. So tangent theta is equal to 250 over 20. And again, you could use sine or cosine if you wanted to, depending on what your favorite trig function is. Second tangent of 250 divided by 20, and I get 85.4 degrees. Okay, since that's this angle right here, I want the angle from 0 all the way around to this. So this, if I go all the way around, is 360. So what I'm going to do is 360 minus 85.4 degrees is equal to theta. So I get 274.5, let's say 275. Theta equals 275 degrees. And so my final answer will read like this. Velocity total is equal to 250.8 at 275 degrees. I'm being kind of loose with significant figures on this page, so give me a little grace on that. That's our total answer. And I also need meters per second, so I have units on everything. Alright, try the back side. Here are your vectors that you're going to add. These two are force vectors, so there's a box or something right here being pulled in these directions. Give me the total force vector. These are also force vectors. There's something right here being pulled at 250 or 350 and 250, and you need to give me the resultant vectors. All right, try those on your own.